Hey, who's all here today? I'm gonna reboot Mewbot here. Mewbot, wake up, man. Who's all here? We'll see who's here, and we'll get some questions going. Hey, who's all here today? I've got the background going. There we go. No more background music going. No more Brian in the background. And I have the Go XLR. Watch me not have been playing music all day. Good, play music. Hey, HTT, what questions do you have, HTT? What would you like to do? We might, if no one has questions, we'll do the 320 activity. Can you use head on inspect? I don't think you can. Good question right there. Because remember, you can use head inside of inspect, but you can't use head on inspect. So the way inspect works is it prints everything to the screen. And so it's not a capturable element. It's kind of like, let me try to show an example here. Let's hop over here. And this is the work we've been doing on this. Let's hop over and do some 474, talking about the inspect argument or the inspect function 474. So when you're working with inspect, which is a lot of times what we use to like inspect rules and stuff like that. Let's put a chunk down here and just talk about it. So the way inspect works, inspect is in the A rules package. And so when you go here to inspect your rules, it's going to show you all your rules. I have 8 rules currently in here. And these are the associations between what people listen to, like someone who listens to Kesha, how it would impact them listening to Katy Perry. So with this, if you want to find the first rule right here, you would think, logically, I could go to head, and then I could put the argument 1 and get the first rule. Oh, what? It actually works? I'll be. Now, it won't work if we inspect. That's interesting. That did work. Well, I'll be. So yeah. It doesn't work. If we inspect the music, these are all the carts people have. But if we go here to this, let's try this. Does head work on that? Is head smart enough to do this? Can I get the first cart? Now you see that doesn't work. I forgot that. So yeah, and exactly what's interesting is it does work with this one, and it doesn't work with this one. So it works. But I would probably do the following. I'd probably go to the head of the rules and get the first rule, and we should get this also, and inspect the head of the rules. So that gets the same thing. So works. Interesting stuff right here, right? Play 100 points. Thank you. Good questions right here. So both of these get the same output. Ooh, oh, look. Okay, so I wouldn't do the first way. What do you notice right here about the first way, which I would not do? Once again, I start off by saying don't do this. What do you notice happens? And I'll show you again. I'll run the output. So watch what we get. Clearing the output, running the output. So it works, but not really. I wouldn't do this. We'll try this right here. I wouldn't do this. It works, but not really. I wouldn't do that. So why does it works, but not really? I mean, yes, but no. Yes, but no. You probably don't want to do all that. So why does it work, but not really? So I wouldn't do this. This down here works. So, well, with the rules, it does work. So this works, but not really. Once again, look at the output I'm getting. I want to see the first 2 rules. Now, please note, this is the output I'm getting from running just this code. So what am I getting here? I'm getting the first 2 rules, but I'm also getting what? This is why it works, but not really. At least, like, we don't want to do that. We don't want to supply extra output we don't want. If we want the first 2 rules, we only want the first 2 rules. So remember, this is the output we are getting when we run this. And this is why I wouldn't run this code this way. I'd use the next code that we have. So once again, the inspect is like the hug around, like you're saying. So what's the issue here? What's the problem with this? Like if I say to you, you show me the first 2 rules and you say, okay, here's the first 2 rules. Well, yeah, it kind of did it, but yeah, well, so then we get this extra right here. So it prints off all the rules and then it prints off the first 2. We probably don't want all the rules printed off. We just want the first 2 rules. So we need to put the head function inside of here. And once again, to show that it's only doing this, this works. Now this one doesn't even work. This one just doesn't even work. Oh, no, this one just prints. Oh, but is it printing off just the first one? It doesn't work. Prints all rules. Prints all baskets, rather. carts, baskets. That prints all of them right there. So we want to go and do the head of music. 1. It's going to do the first element. And then we want to go here and go to inspect. And now we get the first cart. So this is the first person's playlist. A little more clear if we go here and do something like the first 3 carts. These are the first 3 people's playlists. This person has a rather small playlist with library tapes, Max Richter, and the No Twist. No idea. 3B, yeah, we'll talk about that next year. You got it. And so with this, we are doing it the proper way. And we could also go and look at certain, so this is correct way. It's very specific on how you have to do this. You could go here to music, and you could take the 244th cart, and I don't know what that'll return. Yep, it just returns what it is. I don't usually run it that way. But we want to inspect that. And with the inspect, if I could spell, good thing to do is put a space, and then you'll get the completion of it. If you don't have a space, it won't auto-complete. And then there's the 244th cart. Maybe we'll find a little smaller one to look at, the 24th cart. And here's the 24th person's playlist. It does say 1 right here, but that's not the first person's playlist. You can see at the very end of this person's playlist, they have Zoe and Yili. And this person at the end has the following: thievery, corporation, all that. It's just telling you what element you're printing off of a list right here. So make sure to use the inside. Don't go to the outside of it. So this is a correct way right here. And another wrong way of doing it is to go here and to take... And another wrong way to do this. Gotta know the wrong ways. Another wrong way is going to go to here, and we'll just take that, put it over here, and that's going to print everybody. So, and then it says null at the end because it's trying to return the first element of something that it doesn't have. So it's saying there is no first element. So don't do these ways right here. It doesn't even work. Prints all the carts. This works, but not really, and this works. So a little bit of review on there on how to use the inspect, whether you're inspecting rules that you have, or you're inspecting the carts, whether it be music, or whether it be Kroger data, or who knows what you're inspecting, or Netflix data. Who knows? Let's go check out another question coming right up. Good questions to start. Some 474. I'm gonna cough. No. Oh, we were at 3B. Is that 3B? Cool. Okay, let's talk in generalities on 3B. Let's talk a little bit about 3B right here. Here we go. Let's talk some 3B. 3B for 474 on associations. Let's do it. So when we're talking about lift, we're talking about the factor increase to someone's probability of buying something else. Now, I don't want to give the answers away here, but I want to talk in generalities and talk theory on this. So one thing you maybe want to do right here is this for A and B. I'd put 3B right there. Now, when you're looking back for the answers, you can always scroll back through and click 3B. A lot of people don't know that you can just hop to different parts of your code and go down to it like that. Normally, a lift of 1.25 does not get much attention because it's close to 1. So if we had a lift of 1, like hypothetically, that would mean there's no change to the probability. Think of a scenario, a number of fraction of carts with items B in it, where rule A implies B has a lift of 1.25, would imply that the item B is in the cart with 100% certainty when item A is there. So, what was the last answer? I'm totally forgetting. My brain's blanking. Oh, yeah. Okay. So, what we want to look at here, and I don't want to go into too much detail, is we want to look at what this rule would be and what it would imply. And we want to think what lift is. And so understanding what lift is going to be very important right here. Let's go ahead and look at some of our rules. So we need to inspect these rules right here. Hey, you bet. Oh, the PTA one's a great one. Oh, that's a fun one. Rules 2 not found. Did I make rules 1 last time? Okay, let's take a look at these rules. Oh my gosh, look at all these rules. Let's go grab a rule right here. We were just talking about a moment ago how to grab rules. And if we want to grab a singular rule, we're just going to go here and grab this singular rule. So let's think about this right here and what we know. And the interpretation is going to be massively important. What does R mean in the regression equation? That is correlation. Jake right there, good question. R is correlation. R squared is percent of variation explained. And we can do some of those if you want here. Do some regression, all that good stuff. And once again, you can edit pictures. 201 tip right here. If you ever have to edit a picture, you can go to the crop, I am a little bit too crazy on these things. I'm like, no, even a picture I want to use, I want it to look nice and perfect. So, oh, it's got that extra bit on the bottom. Can't have that. Can't have that. So the key to this one is knowing the concepts of what these things are. So when we have the concepts, I am crazy. There we go. Perfect. When we have these concepts right here of what is support, what does the support mean for this? What does the support mean? I'm going to put 30 seconds on the clock, 100 points on the line right here. What does the support mean? Good review. And then you want to think, we'll go through all these mean. How do you find R when you're given a data set? Post your question, Jake, and we can do it. We did one similar to that earlier today. We'll probably find it in Jump. And Jake, if you want to post a question, we'll do it here. It would be the next question after Kayla's, I think. So what does the support mean right here? We're looking at this support. And Jake, great questions. We will definitely do that. Oh, Jake's got the support. Nice job, Jake. Jake, 100 points. Thank you. I think you're asking 201 questions, but you're jumping here. I love it. So that is what is the support? And then we want to know, what does this mean? If you put in Jump, yes, exactly. Kayla, 100 points helping out right there. Kayla's 100% right. You can also do multivariate methods. Kayla earning around 100 points. Thank you, Kayla. So support here, the percent of people who listen to Judas Priest and also listen to Megadeth. So that's like 6.38% of the people who we have playlists on listen to both of these people right here, both of these bands. What does the confidence mean? So given, Zach Mohammed, excellent work. The confidence is now going to be given you have Judas Priest, the probability of having Megadeth is, and then we could put it as a probability, 61.8%. Coverage, not super important. I mean, it's important to know what it is ish. I mean, it's just the support of the left-hand side. Sure, I'll delete it now. So the coverage is left-hand side support. So it's the support of this right here. So coverage is left-hand side support. So what is the coverage? And the coverage is 10.3% of people have Judas Priest in their playlist. What is the lift now? And this is the important stuff. And this is where it kind of relates to our question, but I don't quite want to answer. I don't understand. The lift right here, which is things we need to talk about. What is the lift? Well, the lift is the increase to Judas Priest, Megadeth, the right-hand side, probability, given we know they have Judas Priest. So people with Judas Priest are 5.2 times more likely to have Megadeth. So that's what we're saying right here with the lift. So this means I can go and find the what right now. I could go and find the what right now. What could I go and find, which this is kind of relating to the problem and looking at lift and thinking about what things would mean, when this would be important, and what scenarios this would come into, because you want to think about what the lift is doing and when this would be super important, and when, you'd be very interested in a lift of like 1.25. I don't want to quite say what the answer is this one. Great job, Mohammed, right there. The initial support. They have to think about like what initial supports would be very interesting with a lift of 1.25. That's a big hint for the question. So the original support, wrong button. The original support of Megadeth, we're going to unlift it right here. So we're going to go and take the confidence. So let's put it here. Confidence divided by lift, which is equal to, let's just do it right here. The confidence, which is the new probability, divided by the lift. And there's the original support. And once again, it never hurts to check these things because we can mathematically find this. by just going right here and going to item frequency of the music and going in here and putting Megadeth in here, and we should see that same... Oh my gosh, you gotta be kidding me. Really? I used a code bracket. There we go. Oh, what did I do? What did I do? Did I divide the wrong numbers? Are we doing a subset? What happened here? Dun, dun, dun. The original... What's the probability? Judas Priest impacts the probability of listening to Megadeth. So, the original probability of Megadeth... What happened? Are we doing it for a subset of things? Let me look at the subset right here. Oh, I think we're only looking at a subset. Yeah, it's music too. Okay. There we go. See, change the question. I was like, wait a minute. When the math doesn't work out, if you look at that, does round up. So it's this right here. When the math doesn't work out, something happened, and we were doing a different subset of the data points. So this is a different subset of data right here, a different group of playlists. And so using music 2, which is not music 1. So when the math didn't work out, it was like, wait a minute, we're using a different data set. I know, I freaked out too. I was like, everything I'm doing is conceptually correct. And when the math doesn't work out, but the concepts are correct when you're delifting it. Yeah, so you have to think about, like, just tell me right here, what is the maximum lift? This kind of alludes to the question. I don't want to say the answer, but you don't have to give me exact, but the maximum lift for this is probably close to what? Which I don't want to say the answer, but how this whole thing works out. But what is the maximum amount of lift? Here, I'll make it easier. If that was the original support, what is the maximum lift? So the maximum lift would be what for this? If that's the original support of Megadeth, then what would be the maximum lift? So remember, lift is the factor increase, and we're talking about probability people listen to bands. So the maximum lift, which is kind of hints for the question. So the maximum lift here would have to be what? Like, what is the maximum that could be lifted, which is the factor increase to it? Well, if it was lifted by this, then this would be the change to it. So if that was the lift, then the new probability given someone listens to a band would be this. If the lift is that, then that's the new probability. So what would be the maximum lift? Like, if we say this is the original support of the band, what is the maximum lift right here? Oh, that's for the question, correct. And this kind of alludes to it. Kayla, great job right there. And Mohammed, excellent work. So, but if this, and so this is theoretical now, not to like answer the question of the original, but if this is the support, what is the maximum lift this could be lifted to? And this is just probabilities, Kayla, which is good for Stat 201, because we're just talking about the probability someone listens to a band. So what is the maximum factor increase to that probability? I changed the numbers to make it an easier math equation. So what is the maximum factor increase that we could increase that by, as in multiplying it by a number? But remember, it is probabilities, which follow the rules of probability contained between 0 and 1. 0 would mean no one listens to the band, and 1 means everyone listens to the band. So what's the maximum factor increase we could do? What is the maximum factor increase? And if this one looks confusing, let me make it look easier. What is the if 25% of people listen to Megadeth, what's the maximum factor increase we could do? We're on the right track, but remember, lift is a factor increase. So what is the maximum lift right now? Lift is a fact. So this one's a little bit easier right here. Remember, lift is a factor increase because you're multiplying it by a factor of the lift. Whatever the lift is the factor increase. Well, it won't be 0.75. That won't be the lift. That is the increase. That is correct. But the lift will be what? So this X right here would be what? So Mohammed, 100 points, you're on the right track. The lift is the factor increase. Now, it is lifted by that much, but it's a factor increase. By a factor, we're multiplying it by. So that's what the lift is we're multiplying this by a factor of this. As in, if I take right here, and I take the probability of, do we have the other answers? If I take the probability of listening to Megadeth, which was, here's the probability of listening to Megadeth, and now I'm going to lift it to its new probability. HDT, great job right here. Here's the maximum lift. And what do you notice as this probability gets higher? The maximum lift is doing what now? And this kind of alludes to the question a little bit here. What do you notice as this probability is getting higher right here? Kind of alluding to the question. what do you notice the maximum lift is now? Like, what is the maximum lift? We're just saying the maximum lift, it goes to 2, because you can't lift it as much, because you're saying we can only increase by a factor of 2. So to the original question, what is the maximum value? You can round it. Because if you can kind of do 1 divided by it. What is the maximum lift for this original probability, which our Megadeth thing was close to? The maximum lift for this one, which is the original question, if we have here the support for Megadeth is 0.1, like 1 in 9 people listen to Megadeth. So what's the maximum? The maximum lift. Not 10 though. Not 10. Close, not 10. And so this is 1 in 9. So 1 in 9 people listen to Megadeth. So the maximum factor increase that we could raise this by, not 11. 1 in 9 people listen to Megadeth. Great job. Yeah. I love it. Yep. The maximum factor increase would be 9. Because now, instead of 1 in 9 people listening to it, it's everybody, because we raised this by a factor of 9, and that would be the lift right here. So the original probability of Megadeth, if the lift was 9, now we'd be computing the what. What does, last question here, this right here would compute the what for someone listening to Megadeth, given they listen to Judas Priest. This computation right here of the original probability of Megadeth, so let's say, what does this find? This computation right here of the original probability times the factor increase would solve for the what up top. Good review of the concepts and making sure we understand how to read this output. Always know how to read your output for 201, 324, 74. Know how to read that output. So what does this find right here? Well, we do have the maximum lift, but when we compute this, this solves out to 1, and 1 right here is what? So we did talk about, that is correct. 50 points right there. What is this 1 solved for right now? What is this equation finding? It's the original probability times by the lift. So this is the support of the band times by the lift, which now is solved for the what? So the support, the original support times the lift is going to equal to what? The original support times the lift is equal to what? Not new support. The support is how many people listen to both bands. Oh, close guesses. If this was like theoretically like this is the lift, this is the support, this would solve for the confidence. Now we've changed the numbers on this. It does solve to 1. The way it works, this is the confidence, and we found something like, I'm changing the numbers, sorry if that makes it confusing. This right here, the original probability is this right here, and we would times this by 5.21, and that gives us the confidence of 0.6. So this is the original support times the lift equals the confidence right here. So the confidence is the original support. Guys, good practice right here. So yeah, the review of all these concepts and also talking about what maximum lift would be. We also mentioned a very important thing that, like, I mean, think about this. What is the maximum? This is a big hint. If, like, say, and this is hypothetical. We're going to jump to one right after this. Hypothetically speaking, because it's not the output anymore. I should have put that to when I was doing these hypotheticals. Hypothetically speaking, something has a support of 90% of people. So now, what is the maximum lift? And you could solve this right here. Like mathematically, you can always solve. This equation right here will always solve maximum lift. And if you know lift, you could solve for interesting supports. Some big hints right there to talk about hypotheticals, because that's what the question deals with. Is it deals with hypotheticals, and this equation right here really gets to it. When you look at these hypotheticals here at the end, normally a lift of this, and that's where the x is currently at, but then we could look at original supports and stuff like that. When might be interesting? Yeah, when would it, think of a scenario. Yeah, so you need to name off a scenario and kind of talk about it, make it clear that you're talking about this, and kind of show how it works. You could code it, you could show it. So we've shown some of the mathematics. So everything I've been writing here mathematically could be shown with code to show how this would work and to also explain through what's going on. Well, but remember, it's talking about, it's giving you what the lift is, and then it wants to know when this might be interesting and when this might imply certain things. So you have to be like, okay, well, it told me what the lift is. So lift impacts previous support, which is this. And so it's telling you what the lift is. So now you could talk about certain scenarios and stuff like that. I don't want to quite say how it all works, but understanding what the lift is, what the support is, and then how this might be interesting in some ways, and then explaining that conceptually to someone. Like if your boss says, well, 1.25 lift, that's very small. And you say, but in this instance, it's actually very significant because of these reasons. So think about what this equation means down here. What we've been solving through as we talk through the support, the lift, and the confidence right here. So that equation is support times lift equals confidence. Very important right there. We'll come back and we'll check out more 474. Don't want to quite give it away, but it's a big help with that equation down here on the bottom and going through what support, lift, and confidence all mean right there. And we have chapter 10, the PTA question. PTA question. Really good review of 474 right there. Make sure to know the concepts. Always be like, okay, what does lift mean? What does support mean? And what does confidence mean? All those key terms and be able to show them mathematically. So try solving those equations we just solved. Really good practice. Hopping over here and pulling up chapter 10. The PTA one is a great question to practice because with the PTA question, it has a lot of versions. Sure. Do we choose or change the A of the B in the rules? Well, you'll talk about when it might be interesting. So remember, it gives you the lift, and then it wants to know when these things might be interesting and in what scenarios. So you could mention like if product A was this and product B was this and had a lift of this, it would imply this. So you could make up two things like peanut butter jelly or things like that and be like, well, if product A is peanut butter and product B is jelly and we see a lift of this, but then with certain things, you could talk about it that way. But make sure to show mathematical backing and to think through when would this lift be of importance. PTA one. Ooh, here we go. Stat 201. PTA question. This one's a good one. This one's a great one to practice. Let's check it out. So this is going to go over the different sampling methods, which I still think we have up from yesterday. We did sampling methods yesterday. Got both notes, different sampling methods. And so we need to know the following sampling methods. We have right here, simple random sample. The steps for simple random sample are to give everything a number and then to choose those numbers randomly. The steps for systematic is to choose a random starting point, which they really should say every time we do that, and then to pick every kth observation. And that's going to be a big thing right there. Picking every kth observation is going to be super important to doing a systematic sample. Next is where people get confused. Don't worry, it happens. When we get to stratified, the big thing to know is we are acknowledging a difference. When we acknowledge a difference, we'll be putting things into groups based on this difference, like in-state students or out-of-state students. Then we will sample randomly from those groups, and we will take a percentage relative to those group size. 70% of students are in-state. We want to sample 200 students, so we will sample here 140 students who are in-state and 60 students who are out-of-states because that's relative to the size. Make sure to follow the steps right here that things are put into groups by acknowledging a difference, in-state versus out-of-state students. We are then going to sample randomly from each group, and we will take a percentage relative to the size. People usually get confused on here with the cluster sampling, which when you do clusters, things are randomly put into groups. With things being randomly put into groups, we are then going to choose groups randomly and perform a census on each of the groups. So this is the key to the key to doing a cluster sample right here. The key to doing a cluster sample. And let's go check out our question. So it should say list all the names of students alphabetically and then choose a random student to start at and pick every 10th student from that student. A, B, C, or D. It's one of the easy ones. Like, yes. Yes, we got it. A, B, C, or D. List the name of every single student, then contact the parent of every 10th student, starting at a random student, technically. But it definitely has this element of a certain thing with every kth. Kth is just a placeholder for a number. So you can put in there any sort of number you want. When we see every kth, it's just a placeholder for, what do you want to talk about? The 5th, the 10th, the 20th, the 100th, the 500th, the thousands, 2,000s, 4,000s, 8,000s, 16,000, 32,000, 64,000, 128,000, 256,000. It is A. It is systematic. What kind of bias would result? Now, this is a true sampling method. If you are using one of the correct sampling methods, the choice will always be for these questions. This is a huge hint for this question. The choice will always be bias could result only if the sampling method is not followed properly. So this is the answer if there is no bias. It should just say no bias. As long as we do it correctly, there's no bias. Ask the parents. This is one of the tricky ones. Ask the parents for their opinions when they visit the PTA booth during parent-teacher conferences. We're between two right here. And I think I know which one it is. Which one do you think it is? And I think there's a giveaway if we look at the next part. This is a tough one. This is a tough one. I'm actually not joking. This is one of the ones that can get me off guard. Like this one right here. So with this one, it's not a good one. Voluntary is when people who volunteer their opinions are going to have strong opinions. Convenience is doing things in an easy way. Kind of going for the first or the easiest people to get to, which we do have better access to the PTA, to these people right here. And the people who come and speak to us will be volunteering. It's really a crossover between the two. It's almost one of the reasons I hate this question. Undercoverage bias could result only parents only involved with the PTA will be sampled. Looks pretty good. Response bias could result the PTAs. No, that's non-response bias could result since not all parents will respond. No, I mean that's possible, but under coverage bias could result since the parents in the sample may not be representative of all parents. That's so similar. Oh my God, I hate this one. I'm halfway stumped for the first time in a long time. I'm trying to remember. My brain's like going through all the memories I have of working this problem. And I wouldn't. So undercoverage bias is when I would say there's some undercoverage bias right here. Like, this is the hardest question I've ever had to answer, and it's not a math question on here. Undercoverage bias is when we don't include enough of a certain group. Like if we only speak to in-state students, we undercover out-of-state students, so we leave out a certain voice in the survey. So one could argue, like, I think between all a few of these, because they're all so similar. Undercoverage bias could result since the parents in the sample may not be representative of all parents. That's true, but that sounds just like undercoverage bias could result since only parents involved with the PTA will be sampled. So we're going to a PTA meeting. Ask the parents for their opinions when they visit the PTA booth during parent-teacher conferences. So do we only have a horrible idea? But then we could also have people, like, if we're asking their opinions. It might be response bias. Let me look here. Look at the other ones. I know what that one's going to be. Okay, this right here. This is going to be, this is voluntary. That's voluntary. Okay. So it looks like this is going to be the convenience one. Process of elimination. Whew. So that's going to be convenience because we're doing it in an easy way. Yeah, exactly. So with this right here, since not only are you talking to parents at the PTA, but only those that come to the booth. So response bias, yeah. So now we're having non-biased results since not all parents will respond. It's not that, so not everyone will responding is not an issue. So, but we could have people who choose who not to respond is a big thing. But the way they word this with not all parents responding, we're not going to get everyone anyways. So that's not the issue. Is it representative? That's the issue here. Response bias could result since the parents, and we're talking about this as convenience. So, but they're talking to our person at the PTA booth. So we're going to ask them their opinion. This is where I'm going to get mad at my person right here. But you don't have to be, see, here's the thing. This is where Brian should know PTA stuff, but I'm not a parent. You don't have to be involved with the PTA to be sampled. Like you could go to the PTA booth and not be involved with the PTA. So they're visiting the PTA booth. You don't have to be involved with the PTA to visit their booth. They could say, hey, come over and speak to us. Since the parents and the sample may not be representative of parents. It's a little bit thing too. If parents are going to parent-teacher night, they might be better parents. My parents would, I don't know. Did my parents always go? Randomly select, okay, here's an easy one. Let's do an easy one. So randomly select one neighborhood and contact the parents of every student in that neighborhood. Easy one right here. What do we got? A, B, C, or D? It's easy, but it's tricky. A, B, C, or D for this one. Yeah, you think it's voluntary? We'll find out the hard way at the end of this. I've gone a while without getting something wrong. It's about time, right? This one I know for certain. 100% certain on this one. 100% certain on this one. We're going to go to one randomly selected neighborhood and contact the parent of every student in that neighborhood. A, B, C, or D. This one, 100% certain on. We'll do two versions of this one, probably, or three. Oh, this question's so good. My brain's blanking on that one. So we're going to go to... Oh, I got top chat on again. Live chat. Cluster, Kayla, you're 100% right. Sorry about that. Kayla, 100 points. Better not have changed one of my answers. Kayla, you're right. This is cluster because we are taking a full group and doing a census on it. Cluster does involve a census, but do remember our notes from earlier. When we do a cluster sample, we are taking a census of a group. So this is part of the cluster. So when we do this, we're probably undercovering. So another good review of what undercover is. Undercoverage bias would probably exist because that neighborhood, is that neighborhood representative of all parents? Probably not. Probably not. Put a big ad in the newspaper and say, hey, if you want to respond to this, respond. Couldn't get more voluntary than that. Any bias? Probably going to get... Some bias could result since the PTA wants parents to agree with his plan. No. Voluntary response bias is what you get when you do voluntary. So if we have a problem with this question, I tell you where it's going to be. Wait, random select one of the neighborhoods. What? Really? Did I change an answer? It's got to be this. It is this one. Undercoverage bias could result since only parents involved with it. Okay, so it doesn't mean you're in the PTA. You're just involved with it. If you get that one wrong, tell me. That should win with one of the undercoverages. But I guess it means you're involved with the PTA if you go to a PTA thing. I don't like that right there. Calling that unfair. But it makes sense to me that it's convenience. Because when you think about convenience, it's about getting things really easy. They say, hey, let's just set up a booth at the meeting. And so it made more sense that would be convenience right there. But the undercoverage right here is saying that, you're going to undercover parents who just don't want to be involved. But still, if you have someone asking it, I think there could be some response bias. I would not love this as a test question. Let's do another version of the question because there's so many versions of that. I think that's the only one that ever catches me off guard. So let's do this right here. First one right here. Send a note. We're going to get 100 on this time. Watch. Not going to mess up this one. This is probably one of the hardest chapters because it's very small nuances. It's no math. I like my math. Send a note home to each parent and ask the parent to contact the PTA and record their opinions. What is this? So we're going to send a note home to each parent and ask people to contact the PTA. Looks like we have another what? What does this look like? Send a note home to each parent and say, hey, fill this out and send it back. What are we going to get? We're going to get the people with the strongest opinions right here. So we're going to get the people with the strongest opinions. Voluntary, and that means, boom, we're down here at voluntary response bias. Nice and easy, love it. Randomly select 200 parents and send them a survey. Follow up. Now, it doesn't list the first step right here, which would be to give them a random number. So I'll explain this one. So figure out A, B, C, or D. We're going to choose from all the parents, 200 randomly selected parents by choosing random numbers. And then we're going to send home a survey, and then we're going to make sure they respond so that way we don't get non-response bias. Non-response bias would be that some parents just don't respond, and then we'd get probably some voluntary bias of sorts via the non-response. So what is this right here? Looks like, yep, simple random sample, and this is a good one. If we properly do a simple random sample and we follow up with them, then bias could only result if we don't follow it as described. Select one of the elementary schools and contact the parent of every student. Key concept right here is that we're doing a what? Like, And this one doesn't have any really confusing ones, so it should be easy to see which one it is. But we're doing a census of the school. So we're doing a census of the school. So we're choosing, I see which answers the bias is going to be. It's good. Not quite we are doing it. Yes, I think, yeah, great job, Kayla, right there. We're doing a census, which means we're doing a cluster, or doing census on the cluster, right? And so randomly selected, but is this cluster going to be representative? We'll probably undercover, especially if this is, which elementary school is it? Is, elementary school on different parts of Knoxville the exact same? Choosing one of them to get the views of parents. Is that going to be representative of all parents? Probably not. So undercoverage bias, since the parents in the sample may not be representative of all parents. Select 20 parents from each elementary school. Send them a survey home and follow up with a home visit. This is definitely what? This is an easy one. Not like, don't worry, like, easy, what? This one very much follows exactly a certain strategy, A, B, C, or D. So we've got 21 elementary schools of equal size, let's say, and then we're going to take 20 parents from each school, not taking everyone from each school, and we're just going to have, with acknowledging this difference, like, oh, well, the 21 schools have differences, so let's talk to 20 parents at each school. They're all about of equal size. So we're going to have a poll of parents, 420 parents total, I believe, and there are going to be 20 parents from each school to properly represent each school. So we're acknowledging a difference between the schools. We are definitely doing this now. We are 100% doing this strategy, and it's a good one because we're going to make sure that they respond. So we're definitely doing this. We'll do one more version of this. It's a really great question. Stratified. We're 100% stratifying right here. 100% stratifying, and bias can only result if not followed. That's what you get, Mount Pearson. Let's do one more version of this. We'll go 2 for 3 today. That's what we'll do. So here we go. A little bit quicker on this. Good to see you here, DK. Randomly select 50 parents from each school. Follow them with a survey. If they do not return, this is our stratifying, and bias can only result if we don't follow it. Randomly select 150 parents. Follow them with a survey. Simple random sample, because we're just taking right here. We just did these. Bias can only result. Ask parents for their opinions at the next PTA meeting. Now, this is similar to the one we just did. I think they're trying to trick us again here. So if we ask parents for their opinion, we're not getting everybody. To get everybody is an attempt at a census. So obviously we have convenience sampling right here. And let's see right here. Ready? We're going to answer the same way we answered last time on this trick one. We got undercoverage bias could result since the parents in the sample may not be representative of all parents. Undercoverage bias since only parents involved. Don't get tricked by this one. No way they're changing on us, right? This is a little different but similar. Put a big ad in the newspaper. Voluntary bias right here. And might do one more version. I swear there's a few more. So you can get to see all the answers right here. And then voluntary bias. You're not tricking us, my Pearson. There we go. One more time. Quick swing around right here. We'll get it. Okay. List the names of the students alphabetically and select every 25th student. Earlier when we did, this is the systematic right here. And that is a good way of doing things. We'll try to follow up. Ask the parents for their opinion. That's going to be convenience and only parents involved. Put a big ad in the newspaper. I think we've basically done most of the versions of this. And randomly select 100 parents, send home a survey, follow up. That's also going to be simple random sample. And I think we've done it. As long as we're not selecting, are we getting any different ones? A lot of versions of this. We're going to select one of the grade levels. So new one here, one of the grade levels. If we randomly select one of the grade levels and talk to every student in that grade level, that will be a what? So we'll pause here and then we'll do another question. Put your questions in the chat. We're free of questions after this. We randomly select one grade level and then talk to every student in that grade level. So this will definitely be a what? Like, so you should notice, oh, we're doing a census of this. So it's not an attempt at a census. Cluster, yep. So the grade level right here is the cluster, but that's probably going to undercover so all the parents, because we don't want to just understand one grade level. It's probably going to be a bad idea. This following up with a home visit right here with the 250 randomly selected students is going to make sure we have no bias. So bias can only result if we don't follow it. That's a simple random sample. List names of student alphabetically and contact every 25th. That's systematic. And so bias can only result if we don't follow it. Send a survey home, ask the parents to fill it out. That's going to be... So send a survey home with every student. We're attempting to talk to everybody. And then the problem here is going to be probably non-response. Could result since not all parents will respond. Send a survey home with every student, ask parents to fill it out, and return within a week. Should be non-response. Just some people aren't going to respond. Oh, got scared on that last one a little bit. So when you think about it, if you send a survey home with every parent, the parents who do respond might differ in the opinions than those who don't respond. Maybe you say, do you have enough time to work with your kids? And everyone's like, oh, all of our parents say they're involved with their kids. Well, they're filling out the survey, so they probably have some time. So you're not getting responses from people, and they differ in the responses than the ones who do respond. So great stuff right here. Kayla, do you have more questions? Let's hop back to the main screen. We got hit by that one question. Let's start at 100 points there. Brian making an error. One question. I was like, it's going to get me. Out of coffee, too. More coffee. What questions are there? Could do some activity. Find out. Points given out. Let me pull up the activity for later today. 320 activity. Great job. 320 has been working really hard. Chapter 10, research on pollution. Ooh. Now, this one's hard to find. The way Chapter 10 goes, or I'll find it. They changed the questions. Let me try to find it. I'll show you how it works. I'll show you a question in a second. Chapter 10 is the hardest ones to find. Okay. Is it Chapter 10 on pollution while outside a outside a car dealership? I thought it was the pollution on the ground. Okay. Was it pollution? Oh, yeah, outside a car dealership. Yeah. Yep. So I'll show you right here. Check it out. So if you look at this question right here, it says, researchers want to estimate the percent of people who thought pollution was a serious problem. And so watch this. I change it, and look what it becomes. Researchers want to estimate the percent of people who thought drinking and driving was a serious problem. Obesity was a serious problem. So if you notice, it changes. And state police want to estimate the percent of people with cars with up-to-date registration. So if you look right here, this is sometimes why I have to work these problems. There we go. So do you see right here, Kayla, that this problem right here, which is one problem, has many different versions of it with the state police. So sometimes it's pretty hard to find these problems because the wording actually changes. And so I have to go through the completed problems because it's not showing me the problem unless I keep going through here and trying to find the problem itself. There it is right there again. It's a completed version of the problem, but we're going to pause right here and try to work through this. So let's work through this, but not look at the answers quite yet. Ready? Because we'll find them anyways. The population of interest is what? The population of interest is all people or things we want to understand. Researchers want to estimate the percentage of people. So instantaneously, people are the population. What do we want to understand? Whenever you hear population, make sure you have written down the definition, the things or people we want to understand. Maybe we're studying UT students. UT students is the population. Now, the parameter of interest, what is a four-letter word when we're talking about the parameter of interest? The parameter of interest is what for the population. So think about this. The parameter of interest, when we talk about the people or the things we want to understand, the parameter of interest is the what we want to understand. So hints right there. The parameter of interest is the what. What is it? It's being redundant. So whenever you hear parameter of interest, it's the what exactly. Okay, you got it. You got the hint right there. It's the what. So what we're saying here is, what do we want to understand about people? We want to understand the percent of people who think pollution's a serious problem. That's what we're asking. We're saying, do you think pollution's a serious problem? Someone says yes. And I say, okay, well, that's what I wanted to know. That is the parameter. Now, the only important word right here is parameter. There's a lot of fancy little Salt Bay extra on top of here of population parameter of interest. But parameter is just the thing we want to understand about a population. And population is the group. And then of interest means the group's thing that we are interested in. The group's thing that we are interested in. It's a way to translate it right there back to normal English. Or if that is English. So we're interested in the proportion of people who think that pollution is a serious problem. Sample frame is one of those tough concepts again. Sample frame is going to be the people we have what to. The sample frame is going to be the people we have what to. The sample frame will be the people we have what. Yeah, the sample frame is the one that gets people a lot of times because we want to understand UT students. We go to the library at 5 a.m., and here's the students we talk to. So the sample frame will be the people we have access to. And we're not going to speak to everyone in the library. We could theoretically speak to anyone in the library. It's the list of people we could speak to. But we can only speak to people in the library because those are the only people we're around right now to talk to. So we have to ask ourselves for this question, who are the people we could talk to? Researchers waited outside a randomly selected car dealership to question people. So we're not going to look at the answer. Researchers waited outside a car dealership to talk to people. So who could we talk to? They waited outside a certain car dealership to talk to people. So the better we can do by not looking at the answers, the better we can do on these. That might be the answer. Maybe it would be the answer. That sounds like it could be the answer if you're looking at the answers. I haven't looked at them yet. I would say people who are at that car dealership at that time. Yeah, exactly. People who are currently at that car dealership. Does that make sense? Like, who could you possibly speak to right now? People who go to that car dealership. So probably we're going to see an answer kind of like that. Yeah. So these are the people we could speak to. So Kayla, you're 100% right. That is the answer. And more specifically to be people who are at that car dealership when we go to sample people. Those are people we could speak to. And you can, little broader sense, say people who go to car dealership customers. Like, theoretically, if someone goes to car dealerships, they could be at our car dealership. Yeah, I think it should be more specific. And you see, I don't like all people except those who work at car dealerships. No, it'd be people who are at that car dealership or people who go to that car dealership could theoretically show up. So if you're like, I don't go to car dealerships, I could not, like, you're like, I will never go to a car dealership, never. Well, then I could never sample you. But if you're like, man, I love going to car dealerships, then you're in my sample frame because you could show up. So not the best way to sample. Identify the sample. Once again, the sample is just going to be the people who talk to us. Anyone who gives us their response, then that's the sample. So it's like the people who responded yes, are just the people we talked to. People leaving the car dealership. I don't love the way that one's worded. People, that's not going to be our sample. This is what our sample is going to specifically come from. I don't like that one. Yeah, that could be tricky right there. It should just be the people who speak to us from the... That makes it a little bit too obvious, maybe. If I was writing this answer, I would say I don't like it either. If I was writing this answer, I would say, like, as a written form answer, I would say the people who spoke to us and gave us data from the car dealership. That's your sample. So your sample is going to be the people who actually spoke to you and gave you data. Now, their views goes more towards the parameter. This is more like a parameter and the complement of the parameter, and that's way too broad. So it could be eliminated down to this one, but my Pearson, you got to do better, man. Oh, whoa. Identify the sampling method right here. So it's not that specific, but it could be some sort of cluster because they're doing it at one specific car dealership. I don't know, did they try to speak to everybody? Yeah. So with this, it's more of a cluster sample, and why are they saying cluster? Is because this is speaking to all people at one dealership. So I wish they were more specific on this one. I've done this one a few times, so I know their tricks. But this one right here, they're going to kind of speak to everybody. This is one of the hardest ones, Scale, I'd say, too. The PTA one, I don't usually make that error. I was so bummed about that, but this one's maybe even tougher. This one right here, basically, they're trying to speak to all people as they leave the dealership, saying like, hey, can you fill this out? Hey, can you fill this out? We're going to hang out here today and hand out this card to all people leaving. Hey, can you fill out this card? And they should say that, like, it should say something about, like, they talk to everybody leaving the dealership. Wait outside. Wait outside, yeah. Well, they're going to talk to everybody. Identify who was left out. This is the easy one. Who's left out? I don't go to car dealerships. Probably don't want to go to them anymore. Sorry, everyone. I don't like car dealerships. I'll tell you this much, like, man, they just play games with you. You ever go to a car dealership and you're ready to sign those papers and they say, actually, we have to add on these extra things right here. I was ready to sign papers and then they were like, it'll be $12,000. I was like, cool. And they're like, well, we also have the lot fee and this and this. And I said, no. And they said, well, we can cut the lot fee by $100. And I was like, no, you said 12,000. They're like, but there are fees on top of this. And I was like, no, you say 12,000 is 12,000. They're like, well, we can't do that. Then don't tell me 12,000. I walked and didn't buy from that car dealership. Car dealership I did buy from actually not gave it to me. I just got a 2021 Corolla. My husband left the windows down last night. Oh no, I'm so sorry. Oh man, I'm sorry. It'll be all right. Everything will be okay. Identify any potential sources of bias. So we're going to get views of more of people who go to car dealerships right now. So undercoverage, since those interviews just left a car dealership, or undercovering people who don't go to car dealerships. All that good stuff right there. Superstorm, not just, oh no. Fire stuff outside too. Did it rain yesterday here in Texas? We got a car in the shop right now. Hopefully they treat us right. Had to tow a car to the shop yesterday. And sorry for the delays in replies to emails. I was out of commission from maybe 5 p.m. to like 7 or 7:30. So we had to put a car in the shop last night. Hopefully it's doing all right. Hopefully just battery. Oh, there was a tornado yesterday? I'm sorry to hear that, everybody. We'll head back over here. More questions. So, more questions. Hopefully you find out nothing too bad with the car. My fiance went to turn her key and it went... Nothing. I say it's the alternator. I'm going to get a shirt that says, it's the alternator, except when it's not. And then it'll say, then on the body it'll say, then it could be the blah, 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 like 50 different things. Because I kept saying, I think it's the alternator. My fiance's like, how do you even know that? You're not a car person. I'm like, but I think it is. Because it usually is. She's like, well, how do you know it's usually? I'm like, I don't know. One time I had to fix my car and it was the alternator. So I bet it's the alternator. Is there gas? Yeah, well, that's the thing too, is she just filled up with gas. So she went to the gas station, filled up with gas, and literally couldn't start at the pump. So, like, maybe we should have informed them of that, because it's kind of like, you know, if you go in, you give a history to a doctor. Like, she pulled up to the gas station, turned off the car as one does, and, like, I'm not joking, like, literally, it's what we do. And then she filled up her car with gas, and then car no start. I looked at statistics. It's usually the alternator. So, you know, she was like, I checked and I didn't put diesel in it because, I mean, it's a green pump. Working on chapter 8. Yeah, we can do one right now, Campbell. Which one do you want to do? Name a question. We can do it. We got 32 more minutes. Your call on a question, Campbell. Name the question. We did some this morning, I think. Unless you like fire. I don't like fire. What should we do? Campbell, you can name a question. We'll do a question here. But, yeah, we got it towed last night. $60 tow. Not that bad. I mean, what do you expect to pay? They're only towing it a mile. And so, guy did a good job towing it. Picked it up by its tires. Went underneath it. Got under the tires. And then hooked it onto it. So, got it towed over. And they're going to put the $60 tow on the bill. We'll find out how much it is. But yeah. Just a bummer, you know, you go to get gas and you're like, first one with scatterplot and speed. Is it the bike times? Is it the bike times? Is it the race times? Do some race times. We are in open question mode talking about getting cars repaired. Does that sound like it's an alternator issue to you? I think I literally hear like weird noises outside. There was one day where they're like banging on my window, actually. They're like repairing things around it. Like, what is this dude doing? So, fastest cyclist. Let's get the fastest cyclist one going right here. Here we go. Some fastest cyclist question here on Stat 201. Stat 201, Chapter 8, fastest cyclist. Let's do this. So with this, we're looking at the cyclist times from 1903. And McDonald's was founded in one of these gaps right here, I believe. So, fun fact. I think Kayla said that last time. So when you look at this data, it's a time series, a time plot rather, and all the data is stored right here. So with all the data stored, we can actually make a plot of this and analyze this. Now, make sure you know how to read regression, which is going to be very important for the test. I want to get some original McDonald's and see what that's like some before the McDonald's took it over, when it was back old, you know, just regular old. don't even know the names of the guys who took over. So watch that thing with Michael Keaton. So we've got the data right here. Click this and click over here and then go to copy to clipboard. Copy to clipboard. So I'm going to pause, go slowly here. So this is going to copy our data for us. So when we do this, we're going to copy the data. Copy. Now we're going to hit Control C or Command C. I think it already copies it anyways, but I like to make sure. Control C or Command C to copy the data. The data has now been copied. Make sure you have your data copied by going over here. I'm just showing you again. Clicking here, copy to clipboard, and then copy the data with Control C or Command C. Now go to Jump. We actually want to open up a new Jump data table by going to File, do it, New Data Table. File, New Data Table. Man, I'd love to meet Dave Thomas. Apparently he was an awesome dude. Talking about some like old school stuff right there. He was alive when I was born, but... So Dave Thomas right there. Apparently he would like just give people food. Like he's like, if you come into Wendy's, you know money, I'll just give you food. That's awesome. So File, New Data Table right here. We're going to go to Edit, Paste with Column Names. I'm going to pause on this right here. Edit, Paste with Column Names. I guess shout outs to Chick-fil-A too, because Chick-fil-A has done that for some people with like storms and stuff and catastrophes. So shout outs to them. Really nice when companies like that take a step forward and do things like that. Like whether you not agree with every single thing of every single company, I gotta give shouts to companies that have definitely helped people. It's a lot of times local franchises. So shout outs to the local franchises doing these big things to help people. Because they're the ones like sometimes for their communities doing really awesome stuff. So there we go. We got the data inside of Jump. So now what are we going to do to analyze this data? What will we do to analyze this data, to understand, to analyze this data? So we want to look at this data and make a scatter plot of it. A scatter plot is a bivariate visualization of quantitative data. So we should know right here we're doing the quantitative data one, which is the bivariate visualization of a quantitative X, quantitative Y. We're actually making a time plot because time is on the X axis, and that's all a time plot is a scatter plot with time on the X axis. So that tells us that year is going to be on the X axis and average speed is going to be on the Y, and we need to go here to the Analyze and go to the Fit Y by X. So Analyze, Fit Y by X. With Analyze, Fit Y by X, we make the bivariate relationships right here. I think we got enough room to zoom in on this. It's going to be iffy. Yeah, it works. And so year is going to be the explanatory variable, and it's going to explain why people go a certain speed in these races. Why do people go a certain speed in these bike races? Well, maybe the year explains that for us. So now we can go over here and click OK, make sure these are both blue, that they're quantitative. So here is our scatter plot, and one thing we notice is that we see gaps in the data right here. There's a gap, and we can show it highlighted right here. There's the gap in the data, and then there's a gap also right here in the data, and visually speaking, these are during the World Wars. So we have right here, years is X, exactly the explanatory. Good, I did do it right. I was really worried. Kayla caught an error. Kara, get those big points, Kayla. If I make those errors, you catch them. Already made one error today. Don't want to do that again. So we have right here that years is the explanatory variable explaining why people go a certain speed, and now we can fit a line through this. This will write the regression equation for us. We don't find these by hand when we do statistics. Here is the intercept, and do remember, I'm going to change the way this looks. I know, right? I was like, uh-oh. The intercept right here is B0. The slope right here is B1, and this is the X variable, and this is the Y hat. Let's decrease font size. There we go. Decrease font size. And now we can see the output all at once on the screen. The intercept, which I did change, you don't need to change your output, but this is the estimate of the intercept, which is B0. We are predicting the average speed, which is Y hat. B1 right here is going to be the estimate of the slope coefficient, which has the X variable year next to it. Understanding that this parameter estimate are the estimates of the intercept and the estimate of the slope is very important to know how to write this equation, such that B0 is literally the estimate of the intercept. And B1, which is for like each one unit increase, is the estimate of the slope, and the slope is connected to the X variable, and the X variable is year. Remember, if we can go back in time right here, which we can't, time has been frozen, we could see the equation previously. We can get it a lot easier. Watch this. Redo analysis, and oh, we can't. Watch this though. Redo, relaunch analysis, And now we could see the actual equation next to it. So the actual equation is over here written with all its decimals. Once again, you'll notice that we just have B0 is replaced with the value of the intercept. B1 is replaced with the value of the slope. And also the X variable is the X variable in the model. Very important to see that. So when we are doing this, we want to analyze the linear or not linear relationship. Remember, QQ, straight enough, no outliers, plot doesn't thicken. Are these two variables quantitative? Well, yeah, I mean, it's the year and also the average speed. Those are two quantitative variables. Is it straight enough? It's iffy. More on that later. Mostly straight enough except for here. So mostly linear. Except there's gaps here and there's gaps here. And these are during the World Wars. This is the proper graphic. And look at yours. Yours should also look like that with the gaps with the World Wars, which we identified earlier. Double check, make sure you click the right graphic. The only way to see this is to zoom in. So describe the relationship right here. Well, the relationship is generally linear, positive, and moderate scatter, little scatter, with the gaps in the data. Here we get to the equation. This is not the answer, but it's the format for the answer. Here is where the intercept goes, and here is where the slope goes. So we need to take from our output, which I've changed it so you can't find them, the intercept down here, negative 266.71, because that's rounded to 2 decimal. Make sure there's a negative. That's a big mistake too. And then we need to take the slope, which is 0.153. Are your conditions met? This is the tricky one. I would say no. There seems to be some nonlinearity. So right here, the relationship is not straight enough. There's not any real outliers. What they're talking about right here is there's a bit of nonlinearity in this area. If you actually look at your model, the model is bending around that line. We don't like that. And one way to look at this would be with a residual plot. The residual plot is going to show us all the residuals. I know, right? It's generally linear, but it's not straight enough. Love it. My Pearson, you're the best. So if you look right here, here is the residual plot. Once again, a residual plot is going to be your original plot, but just flat. So here's our original plot on the screen. Let's put the residual plot, a good thing to know. And you can see the residual plot, once again, is your original plot, but just the plot flat. So the residual plot is going to show us that there's a problem with the bend throughout the model right there. So I'm going to say, shockingly, I'm going to say, no, it does not look straight enough. There appears to be some bend throughout the model. Check the answer. We've done it. So hopefully that helps out right there. Campbell, did you have another question, Campbell? We still got 20 minutes or so. Let's hop back here to the main screen. Hopping back. Test questions will be more direct than that. I don't like iffy questions like that on the test. I like to make it very, very clear. Not every question will be perfectly clear, and sometimes I get tricked. Sometimes a question sometimes I'll think, I'll be like, I've done this question a bunch. And then I'll think to the time I made a mistake, like with an accent, and then I'll make a mistake. It's too easy to make errors. Very easy. You could teach the class for a decade and still every once in a while make an error. It's possible. Hopefully we don't make errors. We try to make as few errors as possible. We'll see what questions people have. Oh, no worries, Campbell. Let me know if you have more questions. Hang out for a little bit more and see if there's more questions. Let me see right here. I'm going to get some notes ready real quick. Be right back. Take a look at the slide. You are doing great, Campbell. That's weird. Let's see what people are saying in the chat. One last question. Sure. 474 1G, you bet. And then Cam will put that in there, and then we will take a look. Let's see it here. 474 1G. Let's go take a look at that. To look for outliers and check for the equal variance, a histogram of response variables should be created. Is that from the Canvas content? To look for outliers and check for the equal variance assumption, a histogram of response variables should be created. It doesn't sound correct to me. It sounds like something else should be created. Is that from the Canvas content? It sounds like Canvas content to you, right? That sounds like no. Oh, sorry. Is that Canvas content? That's from the quiz. That looks to be false. Let me read it again. To look for outliers and check the equal variance assumption, a histogram of response variable should be created. What we should probably create is a residual plot. Let me look. That sounds more like residual plot. Yep. There we go. I was like, it sounds like a fill in the blank. So to look for outliers and check the equal variance, residual plot. I was like, because the way you word it may sound like a true false. We would create a residual plot. So the residual plot is going to allow us to look for outliers. So a residual plot allows us to look at all the residuals to see if there's any issues. I was like, because it sounds like a true false. And I was like, that sounds false. Because you can, histogram you could look at outliers with, but you couldn't look at the equal variance. I'll show this right here in a second, like more in depth. But it's going to be the residual plot. And the reason being, and I can show you a little more advanced on this, if we're doing a regression, so let's go over here to where we have a regression. So this is the same sort of thing we're doing in jump right here. And if we go here to check the regression, great job, everyone. Check regression. Here is a residual plot. Here's a histogram. If you're looking at the equal spread of your model, the equal spread of your model would only really be seen in here. And actually, I can show you. We were doing notes like this today. Here's a residual plot. Here's a histogram. Notice which one I have crossed out right here. What are you looking at to get the answer? Hint, here's the histogram. I was teaching this just about an hour ago. So what are you looking at? And Brian made this clear with the output with his 320 class. What are you looking at to see the equal spread and for outliers? What are you looking at to see the equal spread in outliers? So what would you look at right here? Would you look at the histogram, which I've crossed out? Would you look at the histogram, or would you look at the other thing on here to look for equal spread, which this has a huge issue of equal spread. This one majorly has a problem with equal spread. What would you look at to see if there's a problem with the equal spread and with outliers? What could you look at to see if there's a problem with equal spread and outliers? What type of thing would show us the equal spread and outliers to see if there's an issue right there? Residual plots. And what is a residual plot? Well, the residual plot is just your original plot, but, and did I do this already? Oh, I had drawings of it when we were talking about in class. A residual, hey, here we go. A residual plot is when you take your original plot and do what to it? How can I turn this into a residual plot? If I want to make this into a residual plot, I take it and I make it. Really? I can't go back in time? There's no going back in time. Made an error. To make it a residual plot, I take the line and I make the line flat. To make something into a residual plot, you can just literally make the line flat, and then the line will be set to what? The line itself on a residual plot has a what? The line itself on a residual plot will be set to 0. Because anything on the line, exactly, now we can see if there's outliers because we can see how far away they are from the line. So to turn something into a residual plot, which we had in the jump output a moment ago, you just take the line and make it flat. So I think we had it, did we not have in this output? Here, let's go here and plot the residuals, residual plot. And you can see right here, there's different types of residual plots. We mainly look at this one right here. And it's just that line. And this one also has like straight enough conditions because the line's not going through the center. You can also see that some are more extreme away. And that's the same point you see up there, which not really quite an outlier, more a symptom of the not straight enough. So that's what it's asking about. The histogram is really not going to allow you to see the issues. So the histogram right here is not enough. Not bad to make a histogram. Jump does it this way. And when we do it in R, we do it this way. Histogram right here, not the best way to see it. We prefer to look at, with our residual plots, do we have a change in the spread? Which you can see this, especially with a plot right here, that this is going to have a straight enough and a change in spread. So if you take in 201, this is what we do in 320, very similar, looking to see if there's problems with the regression. So a lot of what you're doing in 201 right now carries over to asking, is there, oh, perfect, look at this. Here's the original plot. And how in the world are we getting this residual plot over here? How in the world are we getting this residual plot? How did that residual plot come about? The way to get that residual plot is just to do what? Think of the residual plot as just what? And then you can see right here that there looks to be some sort of problem with the unequal spread, plot thickening, and it also appears here. All we're doing is just taking that line, making it flat. And then you can look at the vertical distance. Turning it, just turn it flat. And so knowing what a residual plot right here is, and don't worry about the advanced stuff about tests and stuff, you're in 201. 320 should know it. And 474, good practice. But we just make a residual plot to examine all the residuals. So although this is just a basic question right here, asking about residual plots, still a good question. Use a linear model to predict a value of y for an x that is far beyond the other ones used for the model. That is an example of what? So this is when we're predicting for an x value far away from our x values that are inside the model. We're going outside the x bounds of the model. It's best that you can answer these questions by not looking at the question answers, but think through and be like, we're going outside the values of the x's that the model was created from. We are whatting. So we are going outside the x bounds of the model. So the x bounds of your model would be like, okay, the lowest value of x is this. I bet we'll do that one next year, Campbell. You got it. So if we're going outside the x bounds in HTD, we'll do the next one right here. If we're going outside the x bounds of the model, so what are we doing if we're going outside the x bounds of the model? X bounds. We're making predictions on a model. We're saying, okay, let's predict for a bike race in like way in the future right here. Let's go over here and predict for a bike race over here. What am I doing by going outside the x bounds of the model? My model only goes up to right here. And if I go further out than the model on the x-axis, I'm doing whatting? The x-axis. When I make predictions outside the x boundary of the model. Within this, we are not doing it. Outside of that, we are doing it. Not quite predicting on... Close, Campbell. Good guess right there. Good guess. Some points right there. We are... And so here's the key word. If you go outside the x bounds of the model... If you go outside the x boundary of the models, you are extrapolating. So that's where remember what extrapolating is when you make predictions outside the x boundary of the model. So remember extrapolation right there is making predictions outside the x boundary of the model. A variable that is not part of the model but affects the variable, the way the values in the model appear to be related is called a what? So when you think about this, we have some classic examples right here. Our classic example is going to be that when we look at something like ice cream sales, and then we have shark attacks, is it that ice cream sales go up and shark attacks go up, or shark attack sales and ice cream sales go up? Something tells me there's another variable right here called summer, where summer is probably increasing the amount of shark attacks, and summer is probably increasing. It's hidden. It's lurking in the background. So summer impacts both those variables as a z variable of sorts. One outside the model, where we might have a model where ice cream explains shark or sharks explain ice cream. It doesn't matter which way we do the x, y. So that is a lurking variable right there. And that's a pretty good definition, one outside the model. That would be a lurking variable, which the other ones are the response. Response is the y variable. Explanatory is the x variable. So this is just your y variable, your x variable. This is a variable not in the model. Pretty good. See, my Pearson, you're making better questions right here. Good question. We did this one last week. We're going to do HTT's question right here. It's a good question right here. Check out last week's video on this. Good stuff right there. Hopping in here, doing a little more. Was 1G. 1G. Where is it? Oh, I'll show you. One G. Here we go. And let's take a look. 1G. Let's do this. Let's look at some rules and let's take a look. So using a single line of code, print to the screen the 3 rules that involve Muse, Arctic monkeys in the consequent. So the consequent is the right-hand side of the rule. The antecedent is the left-hand side. So you have like what starts, antecedent, and the consequent, which is the right-hand side, what comes after, like the consequence of the rule, which is the probability we're interested in looking at changing. So we want to look at using a single line of code, print to the screen the 3 rules that involve Muse and Arctic monkeys in the consequent. Now, I always liked, we should be able to do this. I think I can do it. I think I can do it from memory. Let's do this. Do I currently have some rules? I have 8 rules. Probably might need some more rules. Let me make some bigger rules. Once again, Brian does similar but different work. I cannot state that enough. Brian likes doing similar but different work. So it's kind of meant to help you out right here. I'm not going to quite do the same thing, but I'm going to talk over the theory about how to use the subsetting right here. We're going to change our a priori a little bit right here to a max length of 3, 4, 3. And and then we're going to bring down the confidence to that. And now our rules, how many rules do we have? 129. We're going to bring down this a little bit. This is going to make things go a little crazy. 1,000. Okay, cool. Let's remove out the redundant rules. So here we go. I'm just doing some practice work right here. There's the rules, removing out the redundant rules that repeat, removing out the non-significant rules. Oh, careful. It's music too. Okay, so cool. Might not have went down in rule size. Same amount of rules. Okay, whole bunch of rules right here, and let's talk about how to do this. So we want to only look at a certain amount of rules. So what we want to do is we want to subset the rules. So we want to go here to subset of our rules. Now that's what we're subsetting. We want right-hand side, and that's an A rules function right there to be able to look at the right-hand side, has contained in it. And I don't think it needs both, but I'm going to change it what it wants. Muse and Arctic monkeys. We're going to just have right-hand side has contained in it Ben Folds or Coldplay. Think of a band that might not. Coldplay's one word, right? 0 rules. No rules. Oh, no. Let's try Katy Perry. Oh, it's getting mad at me. There we go. 158 rules. So there we go. Have either Coldplay or Katy Perry. Which, was there no things with Coldplay? Really? Coldplay is never on the right-hand side of the rule? The 3 rules that involve Muse or Arctic monkeys in the consequent. I wonder if mine's similar. I might have a different amount. 1 rule. So there's 1 rule right now, the way I ran my rules. Be careful, I'm not doing the exact same work as you. But how could we then get this 1 rule right here? I'm not doing the exact same. Starting with Chapter 8 quiz, I was wondering if you have... Yeah, we covered it today, earlier today, and we were just doing the bike problem a moment ago, and we did some more, like, just rewind just a little bit and tell me if you can't find anything. Email me, be like, hey, Brian, did you do this problem? We've covered it the last few office hours, but let me know. I think we've covered probably every question in it. Good stuff right there. But right here, we have the 1 rule. When people listen to the Strokes, do we have time to go over the question about the interest rate of a bond? I think we're running out of time, but I did that this morning. Here, I'll put the link in the video. We did that this morning. Let me drop that link. Because we're running out of time. So, morning office hours. Found it. Take your R squared and do what to it? Here it is. This morning office hours. Careful, it needs to be like this. And so we got it right here. Full walkthrough. Is equal to 0. And there's the bike problem us finishing up. And here is the in between. Just doing a little talking right there. Copy video current time. You're welcome. If you're on the bike problem, we just did the bike problem earlier here. We did the bike problem in the morning video too. I don't mind redoing problems, especially when there's no questions. Always ask to like redo a problem. But this right here covers, we also did a lot of the multiple choice for chapter 8. I'll go back through and label the video later. But we did a lot of different chapter 8 problems right here. We did some chapter 12. But we went through and did the problem here for the bond problem. So check that out. Good stuff. Already got 62 views. Love it. Glad this is helping people out. And yeah, we just go through, try to work as many problems as we can. And that's what we do. Got 3 minutes, so we'll finish up right here. But no, thank you, everybody. This has got it. This is the one rule. So I'm going to read off the rule right here. We'll probably end with that. But keep asking those questions. Thank you, NH8 and also Campbell. 100 points right there, both of you. So with this, looking at this rule right here, this says, given someone listens to the Strokes, remember I'm doing a different type of problem, how does that impact them listening to Arctic Monkeys? 6% of the people listen to the Strokes and Arctic Monkeys. This is the support of the rule. Given somebody listens to the Strokes, I am 65.1% confident that they listen to Arctic Monkeys. This is an increase to the probability of listening to Arctic Monkeys of 5.2. So the original probability of listening to Arctic Monkeys was, it's actually pretty high, I'm shocked, was that right there. And we could confirm this. You don't have to confirm this, but you could go to item frequency of music and put here Arctic Monkeys, and you could confirm the probability of listening to Arctic Monkeys is that, and there it is right there. That was the original probability raised by a factor of 5.2. Also, the combination of the Strokes and Arctic Monkeys appear 5.2 times more than we would have expected via random chance, given these two things are not associated. Another way of talking about it. The coverage is the percent of people who listen to the Strokes. Not a big thing there with coverage, but important to know what it is. It's just the support of Strokes, which could be found via item frequency. Last but not least, we have the count, which is actually how many observations there are. So let's write some quick code right here. If we're looking right here, if we want a count of this, then we'd want the people who have all of these in here. So we'd have to go here to subset, music, items. Pretty sure it's items. Yep, it's items. No, don't do that. Items, they have to have both of these. %99%. Notice how it changed colors. And then we want to see that they have both of these right here. Mad about that. And we're taking a subset. Find the length of that subset. That is how many. And ooh, we have 110, 116. Is it? They have both of these. 116. Now, why? Did I misspeak? Is it double adding up? I might have misspoken. Because what we should have right here. Let's say AB. Oh, please tell me I didn't misspeak. There's AB. Oh, did we do it? Oh, it's mad. It's mad. Oh, my comma. My parentheses. Okay. Go away. Let's see here. 1, 2, 3, run. Got it. A plus B minus AB. What is going on? The percent of people who have Muse, the percent of people who have Arctic Monkeys. Never do too much work. Your brain will overheat. We want the percent of people. That's people who have Muse or Arctic Monkeys. This should, and why? The count is 110. And the support is this right here. Double check. Might have been an error. No! Never want there to be errors. I will have to look. We will come back. No! Brian never makes errors. No errors. We'll look at this later. But that is talking about the support right there. It's like something's a little bit off. My brain's probably just need more coffee. We'll find out. We'll figure it out. Email me if you got questions. Going to be teaching here soon. Just a second. 13 minutes. We got this. More coming up as Brian thinks over. We did it yesterday. Those are my calculations from yesterday. Can't let this go. We're doing yesterday right here. Yeah, that's the probability right there. There's 110. Oh, that is correct. What did I do wrong earlier? What's the difference between these codes? Did this yesterday and did it right. Did it today wrong, got it wrong. Length, subset music, items, AIN. Muse, Arctic Monkeys. Is that seriously it? Is it Brian can't read? Might very well be. I think I can't read. The Strokes, Arctic Monkeys. Wow. That was it. And so this right here. Typo. I just didn't want to let that go. I was like, no, not going to let that go. It was a typo. Everything made sense theoretically. And the AIN, I was like, okay, what is that doing exactly then? So the AIN is working. And we do have this all right here. So that's got it. Oh, I just had to have that happen. I was like, no, not letting that go. Well, that's got it. Sometimes when the code doesn't work, sometimes you make a typo and you put in the wrong band. So it was the Strokes and Arctic Monkeys we were looking at right here, not Muse. I think that's the original problem or something. So I took a wrong turn. Wrong turn on the notes. We'll be back here tomorrow, though. Check it out. Or tomorrow. I don't know. We'll be back. You find out. We'll be back. Bye for now, everyone.